We now wrote the equation of the ellipse whose graph is given over here. For this, I'm using the generic equation of the ellipse. That is, the standard equation of the ellipse is x minus h quantity squared divided by b squared plus y minus k quantity squared divided by a squared equals 1. Notice that this a squared is under the term y minus k quantity squared, and this b squared is under the term x minus h quantity squared over b squared. I have written this standard equation particularly for this type of ellipse because this major axis is along the y-axis. That is, the major axis is usually the longest, and for this ellipse, it is along the y-axis. So that's why we have to use this standard form of this ellipse. So first, let's determine the center of the ellipse. The center of the ellipse is at negative 2 comma 0. This is center of the ellipse, and so this equals h comma k. So therefore we see that h equals negative 2 and k equals 0. And let's also determine the value of a and b. A is basically this distance, that is the distance of the vertex from the center of the ellipse. So this distance we can count it. This is 1, 2, and 3. So this distance is 3. And b is this distance, that is the distance of the co-vertex from the center of the ellipse. So we can count this distance, that is this is 1 and this is 2, so it is 2. So therefore we see that a equals 3 and b equals 2. So let's plug in this information h and k as well as a and b into the generic or the standard form of the ellipse. And when we do that, we get x minus h is minus 2. So it is x minus of minus 2. And this is quantity squared divided by b squared, which is 2 squared plus y minus k is 0. So it becomes y minus 0 squared divided by a squared, which is 3 squared. And this equals 9. Let's simplify this. This is negative of negative 2 is positive 2. So therefore this becomes x plus 2 quantity squared divided by 4 plus because 2 squared is 4 and y minus 0 is y. So it becomes y squared divided by 3 squared equals 9. So it becomes y squared by 9 equals 1. And so this is the equation of the ellipse given its graph, and this is the left side of the equation of the ellipse.